Hello folks, this is a short video on some sample problems. Remember, we're looking at Unit 8. So you have these problems that have to do with uh, writing trig functions in one ratio, proving identities, finding the exact value of each trig function. You got to use an identity to do that. Some indifference identities here. And then here you're proving identities. And then, you have the answers here, okay? So again, this is the bare minimum of amount of work. Okay, then on the 8.2, right? The 8.2, the second one. So you have some more problems. You're using double angle formulas, half angle formulas. Here you're proving an identity. This is where you're solving trig equations, a very important idea in trigonometry, and some more trig equations. Not trick equations, trig equations. And again, you have your answers here to help you with that. And that's a good thing. So let's do this. Let's just do a few problems. Okay, let's see. What we have to do is write this expression in one trig function. Well, let's see, cosine of t. Now, cosecant is 1 over sine. So this product together would be cosine of t over sine of t, which is cosecant of t. Not cosecant, cotangent of t. Sorry about that. Okay, that is a quotient identity. Now look over here to the right. It says prove the identities. This is where you use that handout, how to prove an identity. There are two major ways to do it. So let's take a look at the odd problem here, 28. All right, 28. Well, let's see. You got to make the more, I'm going to choose this. I'm going to make the more complicated side look like the less complicated side. So I'm going to start with 1 over cosine squared t minus 1. Now somehow that's equal to tangent. That is a very good question. Well, let's try to add these together. Let's see, what would be the common denominator? Cosine squared t. Okay. So this goes back to college algebra. Remember, this is the same denominator. You just copy the top. Minus. This is missing cosine squared t. So this is minus cosine squared t. Okay, now remember, we're trying to prove these guys equal to tangent. Now, if you're, what I call a flash in the, I want to get it done, move on to something else without thinking, this is not going to be happy time for you. Okay, we're going to copy that down there. Hey, I know one thing. Sine squared plus cosine squared is 1. So 1 minus cosine squared is sine squared. Ah, I see, said the blind man. Okay, that's cosine squared t. Now that's supposed to equal to tangent squared t, but wait a minute, what is sine of a cosine? That's a quotient identity. Sine of a cosine is tangent. Tangent sine of a cosine. So what would sine squared over cosine squared be? That would be just tangent squared. So tangent squared t is equal to the right side, which is tangent squared t. Okay, check mark. Okay, that is one way to do an identity. Okay, we're going to do 38. We need to verify that. Now, obviously, the left side is more complicated than the right side. So I'm going to work with the left side here. But I'm going to do this one a little differently. Now, 1 plus cosine of A times 1 minus cosine of A all over the sine of A. Okay, now this means I'm going to manipulate this, and I'm just going to go to the right or down. Okay, I'm taking the left side. Hey, one thing I know that this is just a sum. This is a sum and difference right here. So that would give me 1 squared minus cosine squared A, okay, over sine of A. Oh, I know what that is. That's just 1 minus cosine squared A over sine of A. But wait a minute, hold the phone here for a second. 1 minus cosine squared A. I know that sine squared plus cosine squared is equal to 1. So 1 minus cosine squared is just sine squared. So I'm continuing. I'm going to do that substitution, sine squared A over the sine of A. And now we know what that is because x squared over x is just x. So this is just going to be sine of A. Now, I worked this left side all the way through here till I got to the end. Now I'm going to rewrite this sine of A. That is equal to what it's supposed to be, which is what? Sine of A. Check mark. Happy face. Okay, jump up and down. Okay. All right, so that's 38. Let's look at this next question together. Okay, find the exact value for each of the following. Let's see, let's do number 2. First of all, it says the sine of 195. Sine of 195, let's see. 90, 180, 195 right here. Hey, we could just put that in the calculator and find the sine. I think it's going to be negative point something. But hold the phone, negative point whatever, that's going to be an estimate because we don't continue the decimal forever. We must find the exact value. So now we're going to have to put our heads together. Well, let's see. We can either do a double or a half. A double or a half. Or we could do a sum. Okay, so let's look at the numbers 195. Are there any values that we're familiar with that add or subtract to 195? Oh, that is a very good question. Well, let's see. 180, and that's 15. That's not going to work. 270, that's going to be 75. Getting closer. How about 225? 225. 225 and 195, that's 30 degrees. Bingo. All right, so the sine of 195 degrees is equivalent to the sine of 225 minus 30. Okay, so we are going to use a sum and difference identity for sine. And I know everybody has that memorized. So if I have two angles, sine of A minus B, that is going to be equal to the sine of the first times the cosine of the second. Remember, this one follows the sines, minus cosine of the first, sine of the second. Okay? So we're going to call this A, and we're going to call this B. Okay, so remember, I'll just rewrite it. I would not do this on my paper. A is 225. Actually, it's sine of A, cosine of B. Okay, cosine of 30, got a little excited there, minus cosine of 225, sine of 30. All right, let's plug in what we know. Well, we know this from the unit circle is radical 2 over 2, but remember, it's negative. Cosine of 30, we know is radical 3 over 2. See, that's why you got to know the unit circle. Minus cosine of 225, that's negative also. Negative radical 2 over 2. And then times the sine of 30, everybody knows that is 1/2. All right, let's do a little algebra. That's going to be minus radical 6 over 4. 2 negatives make a positive, plus radical 2 over 4. And you could write that a couple ways. Here's one way to write that. radical -6 plus radical 2 over 4. Or if you want to get fancy smancy, you could put a radical 2 there, and you could say 1 minus radical 3. Okay, you don't have to do that, but that's a way to do that problem and show the correct answers. Okay, now here's a question. It says prove the identity. This is where we're going through this procedure. Okay, you got to treat these like they're a game or a little challenge. Now you cannot move something from one side to the other side. That's a no-no. It would be smart to get one side to look like the other side. And I always take the side that looks more complicated. Well, 99% of the time. This looks more complicated than this side. So we're going to start with that. 1 plus cotangent of, I'm going to say alpha, over cosecant of alpha. Please don't make this stuff more complicated than it is. Now, my advice, since the right side has it broken up into 2 fractions, and we know that 1 plus 2 over 3 is 1 over 3 plus 2 over 3, right? So we could just break this up to 1 over cosecant A plus cotangent A over cosecant A. Okay, well, I'm using my method 2, where I'm just taking one side and manipulating it. Hey, I know cotangent is really sine of, no, I messed up. It's really cosine of A over sine of A. And I also know that cosecant is 1 over sine of A. Now, I'm going to rewrite that. That's going to be cosine of A over sine of A times what? That's exactly right. Sine of A over 1. And guess what? These guys are going to divide out, and I'm just going to be left with what? Cosine of A. Cosine of A. But remember, I still got that 1 over cosecant. I should have wrote that over here. 1 over cosecant. Okay. Now, 1 over cosecant is just sine, so sine A plus, okay, so then my final answer is going to be sine of A plus cosine of A, and what am I supposed to find? Sine of A, cosine of A, okay. Now, someone's going to say, hey, I didn't really follow you there on that, okay? Notice that when we were working this problem, I broke it down into 2 fractions. Now, this first fraction is 1 over cosecant. 1 over cosecant is 1 over 1 over sine, which is just sine. So I wrote it here, and then I manipulated that second part. Then I squeezed it in here. I'm still manipulating that right part, and then I rewrote it down at the bottom. All right, so hopefully that helps you out. So there are a few problems. These are 5 problems on the exercises for Unit 8. I hope that may help.